Hello, welcome to 13.4, Measures of Central Tendency. Well, this is going to talk about our data before I start reading this. We're talking about the data. We've got all this data spread out. We're talking about where's the middle of that data kind of following? Is it towards one side or the other? Or is it right in the middle? I mean, how are things spread out? Are things clumped up in different places? And that's what we're talking about. And we talk about average. Average is the big one that people look at. What is the average this? What is the average that? What's the average? Or median's another one. And mode. Those are the three big ones. So, start with average. Average is a number that is represented by a group of data, or representative of a group of data. There are at least 4 different averages: the mean, median, mode, and the mid-range. Each will result in a number near the center of the data. Averages are commonly referred to as measures of central tendency. So the first one, what we always call average, is the arithmetic mean, or just simply the mean. This is the one most commonly called average, symbolized by X with a bar on top when it's a sample of the population, or the Greek letter mu. Mu means average for the whole population. So if I take a sampling of people from class and say, what's the average GPA, what's the mean GPA, that would be X bar. If I took all the class, the entire population, that would be the mean. So if I took 5 people, that would be a sample. Took the whole class, that would be the mean, the mu. So the mean, X bar, is the sum of the data divided by the number of pieces of data. So the formula for calculating the mean is X bar is X1 plus X2 plus dot 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 plus Xn over N. And that would be the sum of X. I should have called this X sub 1, or it's X sub I. The sum of all the data points over the number of data points, where this represents the sum of all the data and N represents the number of pieces of data. So the first problem we're going to look at: find the mean amount of money parents spent on new school supplies and clothes. If 5 parents randomly surveyed replied as follows. Parents spent $327, another one $465, then $672, $150, and $230. So we'd add this up: $327 plus $465 plus $672 plus $150 plus $230. And that result will divide by 1, 2, 3, 4, 5. 5 pieces of data. And our average is going to be 368.80. So some spent less, some spent more. As a matter of fact, 2 spent more and 3 spent less. So that would be finding the mean, the arithmetic mean. Median. The median is the value in the middle of the set of ranked data. So if you have like a set of data, the same set of data, you'd rank it from small to large. 150 is the least, then 230, 327, 465, then 672. So if we rank from small to large, the middle value is our median. Now in this country, when they talk about income, they talk about the median income. Because you have people like Bill Gates and Warren Buffett who make billions of dollars, so way up there. And they would mess up the scale a little bit. So you look at the middle value of income in the country. Median household income. And you have people on the low end who don't make anything. So what about if you have an even set of data? It's a very good question. This was for an odd set, it's the middle value. But what if there's no middle? So what if you have an even set of data? Determine the median of the following set of data: 8, 15, 9, 3, 4, 7, 11, 12, 6, and 4. So I'm going to go to the next page. So if you need to pause this, go ahead and pause it. But going to the next page here, I've ranked the data from small to large. 4 occurred twice. That's why it was listed twice. So there are 10 pieces of data, so the median will lie halfway between the 2 middle pieces, between the 7 and the 8. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our 5th and 6th right here, between the 7 and the 8. 7 plus 8 is 15, divided by 2 is 7.5. So the median here is 7.5. It's between the 2 middle, because this is an even set of data. So for an even set, you look at basically the average of the 2 in the middle. Example, or mode. Mode, the piece of data that occurs most frequently. So in this same set of data that we just talked about in the previous example from example 3, which occurs most frequently? Well, the only one that occurs twice is 4. So the mode is 4. Let's say that something else occurred twice, like let's say 11 occurred twice. Then we'd have 2 modes that would be called bimodal, meaning 2 modes. I'm going to go scroll this up a little bit. Let's talk about midrange. Midrange is the value halfway between the lowest and the highest values in a set of data. So midrange is the lowest value plus the highest value divided by 2. So find the midrange of this, the problem we're talking about, the amount of money spent by the parents. The lowest amount spent was $150. And the greatest amount spent is $672. The lowest plus the highest divided by 2. That's going to be $411. So that's our mid-range. So we've talked about the mean, median, mode, and mid-range. That's 4. I'm going to go on to the next page. Feel free to pause that. So example 6, the weights of 8 Labrador retrievers rounded to the nearest pound are 85, 92, 88, 75, 94, 88, and 84, and 101. My Labrador is 75, last time I weighed him. So find the mean. So for A, it's going to be 85 plus 92 plus 88 plus 75 plus 94 plus 88 plus 84 plus 101. We'll divide that whole amount. After we add it up, we divide by 8 because there are 8 data points. 1, 2, 3, 4, 5, 6, 7, 8. And we come up with 88.375 pounds. How about the median? What's our middle set of data? So if we list them out from small to large, we have 75, then 84, then 85, then 88, 88 again, then we have 92, 94, and 101. So our middle, 1, 2, 3, 4, 5, 6, 7, 8, 4 and 5 are the 2 in the middle, and those are both 88. Look at that, that's kind of cool. And for the mode, it's the same thing. We have 2 data points that are 88, so our mode is also that 88. Our mid-range will be 75, the lowest weight, plus 101 over 2. That's 176 over 2. And that is, drum roll please, 88 again. So the mean was 88.375, the median 88, the mode 88, and the mid-range 88. So rank the measures of central tendency from lowest to highest. Well, we have 88, pick which one you want to call that one, 88, 88, and then 88.375. So all pretty close together. And that's a good data set if they're all going to be close like that. The last concept is the measure of position in a data set. Measures of position are often used to make comparisons. 2 measures of position are percentiles and quartiles. So quartiles, you divide the data into quarters. Okay, so to find the quartile of a set of data, order the data from smallest to largest. I've got to scroll this up here. So you need to pause to get the other information. Go ahead and pause now. So you're going to order from smallest to largest, find the median or the second quartile. So your median, the middle value, is your second quartile of the set of data. there's an odd number piece of data, the median is the middle value. If there's an even number of the piece data, the median will be halfway between the two middle pieces. The first quartile, Q1, is the median of the lower half. First quartile, median of the lower half of the data. And then the third quartile is the median of the upper half of the data. Okay. So let's find out what these are going to be. Example 7, it says the weekly grocery bills for 23 families are as follows. Determine Q1, Q2, Q3. So if we list these out, 50, 74, 75, so 50, 74, 75, 80, 81, 95, 130, 160, 170, 170 again, 172, 190, next one's 210, 215, 225 occurs twice. Is the weekly bill? Wow. 240, 270, 270. That occurs 3 times. Then we have 280, 310, 330. Let's see if you can see that on the camera. There, we got it all now. So let's count this up. 23 families. So 11 plus 11 is 22, so 12 would be the middle one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 190 is the middle value. That's our median. That's our Q2 or the median. Now the lower half of the data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll go with the sixth value, 1, 2, 3, 4, 5, 6. 95, that is Q3, or Q1, excuse me. That's the median of the lower half of the data. 1, 2, 3, 4, 5, 6, 270 is our Q3. That's the median for the upper half of the data. So Q1 equals 95, Q2 equals 190, and Q3 equals 270. Now I'm going to do one more thing with this that wasn't in the assignment, but make a box and whisker plot. That should cover it. Now our median was at 190, so right about here. Draw a vertical line there. And then we have Q1 at 95, so just right about here. And Q3 to be 270, so let's say right about there. And this is a box you get from here. So in the box, your median is the middle, not necessarily the middle, but your median is inside the box, your Q1 is on one end of the box, Q3 is on the other end. Then we're going to draw whiskers. We're going to go out to 330 here. And then the lowest data point was 50, so right about there. So there's a box and whisker plot. Now there are things you can talk about, outliers, and they're like if interquartile range is this difference here, which is between 95 and 270. If it's 1.5 times this range away, then it would be an asterisk as an outlier. It wouldn't be part of the main data group. Those are outliers, and they fall way outside of the main body of data. Okay, that'll do it for 13.4, measures of central tendency. So send me your questions. Thank you. Just want to show you the bottom of that graph. So there you see it. Okay. Bye, guys.